So, we're going to start our eighth grade mathematical journey today with a discussion of rational numbers. Don't be surprised if the concepts in this video are familiar. It is basically a review lesson to get started. Our essential question throughout the unit is, why is it helpful to write numbers in different ways? And we're going to start today by talking about expressing rational numbers as fractions, mixed numbers, decimals, and percents. So right off the bat, please note that this page 7 means in your volume 1, that's where you can find what's on the screen. If you don't see a page number and instead see a little yellow notes page, that means it's not in the book. You might want to head to paper if you need to do any work on those pages. So first of all, the question I want to ask you is, do you remember what a rational number is from our discussions in 7th grade? If you're having trouble thinking of it, let me get you jump started here. But a rational number is a number that can be written as a ratio, or another word would be fraction, of two numbers. So a numerator and a denominator, comparing something to something else. Oftentimes it can be part to total or part to part, something like that. So we're going to look at these four things and ask ourselves, are they rational numbers? So if we take a percent like 19%, can we write that as a ratio, as a fraction? Remember, the percent is per 100, so this would be 19 per 100, 19 over 100. There is our fraction. That's how we can prove that a percent here is a rational number. Let's take a decimal like 0.52. Is that a rational number? Well, if we can write it as a fraction, then the answer would be yes. Now remember, the first place is the tenths place and the second place is the hundreds. So this is 52 hundredths. So there is our fraction. So that is a rational number. Now before we go on, we need to remember, and I will do a quick review with you in a second, how to simplify fractions. And what I notice right here is that these are both even. So I would cut them in half, divide them by 2. 52 divided by 2 is 26. 100 divided by 2 is 50. And oh my word, look, they're even again. If I cut them in half again, I get 13 over 25. 13 is a prime number. Nothing going on there that they're divisible by, so I am done. By the way, 52 and 100 were divided by 4. And if you saw that, you could have gotten to the 13/25 faster. Okay, and obviously a fraction is a fraction, and I'm just, 3/4. Oh, by the way, it's 0.75. There are decimals that you should know, fractions and decimals, that they equate. 3/4 is one of them. But a fraction is obviously a rational number. And then finally, a mixed number, something like 3 and 11s. Now, would that be a rational number? Can we write that as a fraction, comparing a numerator to a denominator? And here, if we do what I call the circle, start at the whole, multiply by the denominator, add the numerator. So you go around in a circle. First you multiply, then you add. So you'd have 33 plus 1 is 32, and that's your 33 plus 1 is 34. Whoops. That's your numerator, and then your denominator would be 11. Since I was able to write that as an improper fraction, that is also a rational number. Just so you know, you can see the word ratio hiding inside rational. So just if you remember that a rational number can always be written as a ratio or as a fraction, you'll remember what rational numbers are. So here's an example, a real world example of, we have a Texas Ranger baseball player that made 126 hits out of being at bat 399 times. We want to write a fraction, and then we want to put it in simplest form. So we're comparing the number of hits, which would go on the numerator, to the total at bats. And there is our fraction, and here is our rational number. I just want to take a minute, though, to remind you how to simplify fractions, and I'm going to remind you of really the basic 4 rules, and then I call it the weirdos after that. So you're going to start by looking, is it divisible by 10? So you look at both numbers, and if they both end in 0, then it is divisible by 10, or possibly a greater power of 10, but at least 10. These are not ending in 0, so we're not dividing by 10. The next thing I want you to look at is the 5. Do your numerator and denominator both end in either a 0 or a 5? Since that's not the case here, we're not divisible by 5. The next one I actually look for is even. Are both numbers even like we just did a second ago? Well, the 126 is, but the 399 isn't. So we cannot divide by 2. The fourth rule that I look for is the divisibility by 3. Is the sum of the digits divisible by 3? So what I mean by is add 1 plus 2, you get 3. Add the 3 plus 6, and you get 9. Ooh, look, 9 is divisible by 3. Okay, so now let's look at the denominator. 3 plus 9 is 12, and 12 plus 9 is 21. Hey, 21 is divisible by 3, so both these numbers are divisible by 3. So 126 divided by 3 is 42, and 399 is 133. Now we kind of ask ourselves, can we do any more? So the 4 plus 2 is 6. Ooh, maybe we can divide by 3 again, but notice the denominator is 7. So the last thing I ask you to look for is kind of what I call the weirdos. Some of your like prime numbers, like 7, 11, 13. And I notice right away that 42 is the product of 6 times 7. So is 133 divisible by 7? And it is. So our final reduced simplified fraction would be 6 out of 19. So that's just a quick review of the divisibility rule, and this will be on a filled-in presentation that you'll be able to access on Classroom after we get through doing this video. Okay, so again, page 8, you'll find this. So a rational number is a ratio of two integers. So just remembering what those number groups are called. When you were a little kiddo, you started by just counting everything, and those were called the natural numbers. So 1, 2, 3, 4, 5, 6, and on and on. At some point, maybe around kindergarten, you started to understand the concept of 0, and you added 0 into the group, and now we call them the whole numbers. Somewhere at the end of elementary school, you started understanding that there was negative numbers, and when that happened, that created an integer group. And then last year, we pretty heavily talked about rational numbers. Now, this bottom part is not on your textbook, or in your textbook, I should say. So I'm recommending that these are sort of the 3 things I look for. If you can find a fraction, a terminating decimal, or a repeating decimal, those are all your rational numbers. So who is not a rational number? Well, something that would be a decimal that doesn't repeat and doesn't terminate. And a really good example of that would be pi. So if you have a number that's decimal representation never ends or never repeats, that would not be rational, and that's called an irrational number. So I just want to remind you about bar notation and about repeating. So if you had a number like 8.63636363, you don't have to write it this way. You can write the 8.63 and be really careful. People can get sloppy with this bar. Make sure you are covering only the parts that are repeating. In this case, it would be 63. You wouldn't just put 6. And be careful down here that you put the bar only on the 4, not the 3 and the 4. So it can be really easy to kind of get sloppy with that, but please be precise. Okay, so just to remind you how you go from a fraction to a decimal, and I'm going to add percents, which your book doesn't do, and that's why you're not seeing this in your book. So we're just going to practice too. So in order to go from a fraction to a decimal, you're going to take the numerator divided by the denominator. That'll always work. Some of you might already know what the decimal is here. You might remember that. But remember that you can always take 3, and this is another symbol for division. So 3 divided by 5. And if you do that, you would see 0.6. And like I said, some of you would have seen that this was 6/10. Now to go from the decimal to the percent, you're going to take that decimal and move it to make the number bigger. You're going to move it 2 places to the right, which would give you 60, and then add the percent sign. So when you look at 3/5, 0.6, and 60%, those are all the same value. They're just a different way of writing it. So the 3/5 could be my name, Mrs. Woodruff. The 0.6 could be my full name, Nancy Woodruff. The 60% could be Mrs. W. They're all the same person, but three different ways to write it. So these are all the same value. 1 and 5/7, the book likes to say you got to go to improper number. I disagree. If you have a whole in front of the fraction, you're going to have a whole in front of the decimal. So just put that 1 in front and then forget about it. And then do the same thing you did up here. 5 divided by 7 would give you 0.714. Put the 1 out in front, and 1 and 5/7 is the same thing as 1.714. Now to make a percent, you're going to move that decimal 2 places to make it larger. So 2 places to the right, and then add a percent sign. And we do, as we enter into 7th and 8th grade, you do keep a decimal at least on your percents to be more descriptive and more precise. So in the book on page 8, they do an example, 5/8. They take 5 divided by 8. They actually do it longhand. I am allowing you to have a calculator. And when you take 5 divided by 8, it would be 0.625. You're going to notice I put a line through example 2 because I think they're making it more difficult to do -1 2/3. Just put that -1. If the fraction is negative, the decimal is going to be negative. So put that -1 in front of the decimal, and then just take 2 divided by 3. That would be 0.66666. You notice I'm using my bar notation. So what I'd like you to do is pause the video, and in your textbook, can you write the fraction for each of these? Write the decimal for each of these, and then when you're ready to go, hit the play button, and we'll come back and check how you did. Okay, 3/4. I'm hoping you didn't even have to pick up the calculator, right? But 3 divided by 4 is 0.75. If it's a negative fraction, it'll be a negative decimal, and 2 divided by 9 is going to give you a repeating 0.2222. So notice I'm putting a bar over the 2. You may have the 0 in front of the decimal, or you may put just -0.2 repeating. I put the 0 because the calculator often does. The 4, if it's in front of the fraction, it's going to be in front of the decimal, and then 13 divided by 25 should be 0.52. Some of you might remember from last year that you could have made this hundreds as well and gotten to the 0.52 that way. 3 goes in front of the decimal, and 1 divided by 11 is going to be 0.090909. Make sure your bar is over both the 0 and the 9. And that's how we switch fractions to decimals. So just going to take a minute before we kind of go the other way is to remind you of how to round. So when we are rounding a number like this to the 100th, you're going to find the decimal. And remember, you've got tens, hundreds, thousands. There is no ones place. So what I basically want is I want to stop at the 3. So 125.0, and I want one more place. Now you're going to not even pay attention over here to that 4. So just don't even look at him. And then take that 7 and say, will that bump the 3 up or not? Since it's 5 or greater, you are going to bump up the 3 and make it 125.04. So notice we're at the hundreds place. Now when we go to the 10th, we're going to take everything off of this number except one place past the 10th. So we're not going to look at any of these. We're going to stop at that 4. And now we're going to say, will the 4 bump up the 0, or will it stay a 0? And since it is not greater than or equal to 5, it will stay as a 0. 230 and 625 thousandths, the first thing we need to do is write that as a number. So the 230 will go in front of the decimal, and the 625 thousandths will go after it. And now we're going to round to the hundredths. So again, we're going to stop at that second place, and we're not going to even look at this 5. We don't even care about that. Will the 2 bump the 6 up or not? It will not. So rounded to the thousandths, it'll be 230.6. And you'll notice I'm using our approximation symbol. And how about this guy to the whole percent? First thing we're going to do is change it to a percent. We're going to take the decimal off, round it move it 2 places to the right, and that will be our percent, like we just did a minute ago. Now we're going to round it to the whole percent. So 79.94, we're not going to look at the 4, and the 9 will bump this up and make it 80%. So that is just a quick reminder of how to round decimals. We already talked a little bit about, the baseball at the start. So there is another example, number 3 on page 9. But what I'm going to ask you to do right now, so you can refer to that as you need to, is I'm going to ask you to do Got It E. I'm going to ask you to pause the video and see if you can write, first of all, you're going to write a fraction, and then you're going to put the decimal to the nearest thousandths to find the part of races he won. So please pause the video, come up with your answer, and come back and we'll see how you did. All right, so 6 out of 36, both divisible by 6, that reduces to 1/6. Take 1 divided by 6. Did you get a decimal of 0.167? That answers the question. I'm going to take it one step further, though. Remember how to change to a percent. Move it 2 places to the right and add the percent sign. So the last thing is we just want to go the other direction and just remind you how to go from a percent to a decimal to a fraction. So we're moving backwards. And again, your book doesn't have this, so I'm just kind of doing a little step off the book right now. So the first thing you do is remove the percent sign, and this time the decimal is going to go smaller. If you think about the alphabet, P going back to D, you would move to the left in the alphabet, so the decimal is going to move to the left too, and you should see 0.65. For 278, the decimal is the invisible decimal. It's hiding at the end. If you can't see a decimal, it's after the last number. Again, take off the percent and move it 2 places to the left, and that's how you go from a percent to a decimal. So now how do we go from a decimal back to the fraction? So the first thing you're going to do is name the place. Determine which place the last number sits in. Tenths, hundreds, thousands. And the minute you say that number, that will be your denominator. Now don't forget that chart I gave you. How do we reduce this? I'm going to check for divisible by 10. They would both end in 0. Nope. But I do notice a 5 and a 0, so I'm going to divide them both by 5. And then I look to see, is there anything else? Are they both even? Can I divide by 3? And I check through those rules, and that one is completely simplified. If it's in front of the decimal, it's going to be in front of the fraction. So put it out there and forget about it. Tenths, hundreds. The 78 is sitting in the hundred spot. So there would be my fraction. Now notice, not divisible by 10, not divisible by 5, but I can cut them both in half. And then I look to see if I can go any further, and I can't. So it's 2 39/50. So that was a review of going from fraction to decimal to percent, and then back again. So this again is kind of a notes, but here's just naming the places, and I'm giving you an example here of how to simplify. And this again will be on the presentation, but just reminding you that there's no ones place, and I'm doing another problem out for you. If you need to pause, take a look at that, make sure you're comfortable, please do it. And if you're ready to move on, let's go. So here's our chance for you to do a little practice. Here's another example on page 9. So, 45 sits in the hundreds place, tenths, hundreds, both divisible by 5. 45 divided by 5 is 9. 100 divided by 5 is 20. Can't divide by 3. They're not both even, so I am finished. Okay, would you please pause the video and do the last got it here on page 10, or excuse me, F, the got it F on page 10. Okay, if it's negative, you're still going to be negative, and the 14 is sitting in the hundred spot. I notice right away, not divisible by 10, not divisible by 5, but they are both even, so cut them in half. And then ask yourself, is there anything else I can do? You can't, and you are finished. I would like you to pause the video and try these 5 problems. We are pretty much done for today. When we come back, I'm just going to do one extension problem with you, and we are finished. Okay, let's see how you did. 16 should be 0.5625. There were no rounding directions, so you would just leave that. Number 2, negative, the 1 goes in front, should be 725 after the decimal. And then 4.83 and only the 3 repeating. 7 out of 16, divide that. There was no simplifying the fraction. You should have gotten 0.4375. It's asking you now to round to the nearest thousands. So tenths, hundreds, thousands. You should have ended with 0.438. 0.438 as your final answer there. And then the changing to a fraction, 32 over 100, and cut them in half. And you should have gotten 16 out of 50. Oh, they're still even. Cut them in half again, and you would get 8 out of 25. You could have divided by 4 and gotten there directly. So that is where we need to be for today. But I'm going to take 1 minute for just to show you an example, because somebody out there is saying, but Mrs. Woodruff, you said that like a repeating decimal is also a rational number, but how do you write a repeating decimal as a fraction? Because it never ends. How do you name the place? And you would be right. So the book does this example on page 5, example 5, page 9, example 5. So I'm just going to show you one, and I'll do one with you in class, those of you that are there on the next class. But this is an extension, a challenger for all the people that said this was old hat, Mrs. Woodruff, we got it all. So what I'm going to do is I'm going to let a variable equal this number, which is 0.5555555. And I noticed that one place is repeating, and one place in decimal talk means the tenths place. So I'm actually going to multiply the left-hand side of this equation, the n by 10, and the right-hand side by 10. When you multiply an equation by the sides by the same number, the equation stays equal. I got 10n on the left, and when I multiply by 10 here, the decimal is going to go around the 5, and I'm going to end up with 5.55555. I'm going to rewrite, I'm going to bring this n equals negative, 0.555, and I'm going to line it up, and you're going to notice I'm putting a minus. So I'm going to take the 10 n's, and I'm going to subtract n on this side, and on this side, I'm going to subtract what n equals, which is that 0.555. And what it does is it takes away the repeat and leaves just the 5. Some of you are going to remember from a one-step equation, divide both sides by 9 to undo multiplying by 9. And there is my fraction for 0.5555. And if you don't believe me, pick up your calculator and put 5 divided by 9 and see what decimal shows up. So this is an extension. I just wanted to show you that you can take a repeating decimal and you can write it as a fraction, but you have to use some algebra in between. So I'm hoping that everybody was A-okay up through here. If this is a little bit kind of gritty, that's okay, but I wanted to expose you to it. So just remember, how can you determine if a number is a rational number? There's 3 things you look for. Can you write it as a fraction or a mixed number? So all fractions and mixed numbers are rational numbers. Is it a terminating decimal, a decimal that ends? Is it a repeating decimal? All of those kinds of numbers are called rational numbers, and the ones that aren't, right now I want you to think of the non-repeating decimals. Think of pi for right now. So that is our first kind of review lesson today about rational numbers. I hope you have a great day, and I will see you soon so we can practice.